Hello and welcome. Today, let's look at how to solve this problem on Ohm's law. Given this simple electric circuit, what is the current through this circuit? So we have a circuit that has two resistors, 2 ohm resistor and also a 3 ohm resistor. And we have a 6-volt potential difference across these two resistors. We are to find the current running through this circuit. So of course, this is a closed circuit already, and we are going to see how to find the total current in this electric circuit. Of course, this is a simple electric circuit. We are going to find the total current that is running through this circuit with a potential difference of 6 volts applied across two resistors in series. So this is a problem on Ohm's law. It says that the potential difference delta V across the load in the circuit is always equal to IR, where I is the current through the circuit, and then we have R to be the resistance in the circuit. In this case, we have two resistors. One is R1, which is 2 ohms, and then we have another one R2, which is 3 ohms. And then the potential difference delta V is 6 volts. And we are going to determine the current running through the circuit. But let's analyze this circuit. Since we have a potential difference, the conventional current is going clockwise. So it is going to run from the positive terminal through until it gets back into the negative terminal. So the current I is going to run in this direction, and we can use Ohm's law, which says that the potential difference is equal to the current times the resistance. Okay, so here we have delta V is equal to IR. The goal is that we want to find I. So to find I, we need to isolate I in this Ohm's law equation. So we divide both sides of the equation by R. Once we have this R cancels this R to 1, and then 1 times I is equal to delta V, which is the potential difference, divided by R. Now we know the potential difference to be 6 volts. However, for this whole circuit, the total resistance is going to be due to these two resistors in series. And for 2 or more resistors in series, the total or equivalent resistance is going to be the total sum of the individual resistors. So we have R equivalent, which is total resistance, is going to be R1, the value for the first resistor, plus R2, the value for the second resistor. If we have more resistors that are in series, then it's going to be plus all the way to the Rith resistor. Since here we have I equals 2, we are going to have the total resistance to be R equivalent to be R1 plus R2. Now R1 is 2 ohms, so we have 2 ohms plus 3 ohms, and this is going to be equal to 5 ohms total resistance in this electric circuit. So in terms of R, we put this R equivalent, which is 5 ohms, because the total resistance in the circuit is due to the combination of these two resistor values of 2 ohms and 3 ohms. And for resistors in series, the total resistance is found by adding the individual values of the resistors together because they are in series. Next, I'll solve a problem on when they are in parallel. All right, now we have I, the current, which we are interested in calculating, is going to be equal to the potential difference, which is delta V, divided by, instead of R, we have R equivalent. So we are looking for the equivalent resistor because that is the total resistance to this circuit. Now we can plug in our values. So we are going to have is equal to delta V, which is 6 volts, and then divided by R equivalent, which is 5 ohms. So 6 divided by 5 is going to be 1.2 volts per ohm. And this is the same as current is equal to 1.2 amperes. So this is the value of the current running through this circuit. All right. If you found this helpful, like, share, and follow so that the algorithm is going to push this video to more high school students. Until then, I'll see you in the next one. Bye-bye.